find the integral of x cos x dx. So we have a product which makes integration by parts an option. We should consider, is there a substitution that could transform this into something much more manageable, and there isn't in this case. So we're going to look at using integration by parts. Now the by parts formula is that the integral of uv dashed equals uv minus the integral of u dashed v. So what we need to do, we need to label this expression in such a way that one's the u and one's the v dashed, and we can pick either one to be the u and either one to be the v dashed. But if you can pick the u in such a way as to when we differentiate it, it's going to be really friendly, then that would be really useful. Or say we could pick something that's a lot easier to integrate than to differentiate, then we might do that. So what we are going to do is go for the x as u. The reason for that is because when I differentiate that, u dashed, which I can see I have in the formula that we end up with, u dash is just going to be 1, and 1s make things a lot easier always. So cos x, if you think whether I differentiate that or integrate that, it's going to be almost the same anyway, so it doesn't really matter. In fact, integrating it is nicer because there's no negative. So we're going to call that the v dashed. So now I want to know, well, u dashed v dashed. So we've just said that u is x, so that must mean that u dashed is 1. V dashed is cos x, so v must be, well, what would differentiate to cos x? And that is sine x, and it's positive. So now the integral equals, so I'll call that the integral. So the integral equals uv, so x times sine x, x sine x minus the integral of u dashed v. Well, u dashed is 1 and v is sine x, so it's just sine x dx. Well, it's really getting quite nice, isn't it? So x sine x is finished. The integral of sine x is minus cos x, because minus cos x would differentiate to sine x. Then you've just got to times it by this minus that was already there. So actually this is going to end up being plus cos x, and then don't forget the constant of integration, so equals x sine x plus cos x plus the constant of integration, and that is finished.